Next, let's review the consensus protocol algorithm. The consensus protocol algorithm is software that decides if a non-root AP becomes a MAP or an eMAP AP. If an AP cannot detect a gateway connection or connection to a controller directly on its Ethernet interface, the AP will run the consensus protocol. The consensus protocol comprises a packet called an eBeacon, which has the following elements: a single MAP bit, the source address, a hop count, and wireless link metric. The rules are: 1. All nodes except a root may advertise an eBeacon. This happens on a once per second basis. 2. An eBeacon is never forwarded over a wireless interface. Rule 3. The AP will become a MAP if the AP has the best uplink. 4. If another AP is advertising a better uplink, then it becomes a listen-only AP. If 2 or more APs are advertising the same uplink, then MAC addresses may be used to break the tie. Rule 5. Before becoming a MAP, the AP must enter a consensus state. This is a 5-second period which waits for the link state to stabilize. If no one during that period becomes a MAP, then the AP with the best uplink will set its MAP bit and claim MAP status. And finally, Rule 6. The proposed wireless uplink must be stable for up to 10 seconds before an AP may claim MAP status. Here is a consensus example that we'll use in the next slide. We have 3 APs that are wired together on the same Layer 2 Ethernet network, meshing APs A, B, and C. In this example, all 3 APs are powered on and rebooted at the same time. The next slide will walk us through the consensus protocol calculations. In this example, we see that APs A, B, and C are all powered on at the same time. Access point C evaluates the link to the root AP and has the best link quality. It then begins the consensus protocol. Seeing that it has maintained the best link quality for 5 seconds, it sets its bit to MAP. Several seconds later, APA updates its link quality and has a better path metric. Several seconds later, APA updates its path metric, which is better than APC. After the consensus period of access point A, APA sets its MAP bit. However, A is not able to hold the link state for the consensus period and then demotes itself, clearing its MAP bit and going to listen-only AP mode. C, then having held the consensus period, becomes the meshing AP. Let's review another scenario. In this example, APs A, B, and C are all rebooted at the same time and are re-evaluating the path quality to the root AP. Here, APC has the best path quality. It then begins the consensus period. After a 5-second interval, APC claims the MAP bit. However, before a consensus can be achieved, access point A advertises a better path quality. However, before A can meet the consensus period, the path quality of A drops. APC then satisfies the consensus period. APC then restarts the consensus period. After satisfying the consensus period, APC finally becomes the MAP. Let's review the consensus protocol in more detail. Here we see that APs A, B, and C reboot at the same time. Access points A, B, and C are re-evaluating the link to the root AP. Access point C reports the highest path quality of 30. After a period of 5 seconds, access point C sets its MAP bit. However, before the consensus period can be satisfied, access point A reports a path quality of 40. As soon as A reports a path quality of 40, C relinquishes the MAP that it set and becomes a listen-only AP. The consensus period then starts for A. However, before access point A can satisfy the consensus period, the path quality of A drops. As soon as A realizes that C has a better path quality than A, it sets its mode, and then APA relinquishes its MAP setting and becomes a listen-only AP. APC, then having the highest link, sets its MAP bit. After the consensus period has been satisfied with APC, APC then becomes the MAP. In order to prevent flap dampening, APs must see at least a 30% difference in link quality before changing state. In order to enhance loop prevention, the APs will first break and then recover a connection. APs will tear down an existing wireless link if any of the following conditions occur. If suddenly the AP detects a gateway on its Ethernet interface, or if the AP suddenly detects a root AP on its Ethernet interface, or if it detects another mesh AP or an AP with the map bit set on its Ethernet interface. If any of these conditions occur, the AP will immediately tear down its wireless link. While evaluating different paths, the AP will always bias a selection towards the eMAP. This increases channel diversity and increases the overall mesh capacity by having an AP with another channel set. In making path selection decisions, the AP will always bias and select an eMAP as a parent over a map. This increases channel usage by creating more channel diversity, which increases overall mesh capacity. SmartMesh will also evaluate paths and select stable links over highly varying links. These are just a few of the mechanisms for improving stability and performance in SmartMesh. Let's review some of the limitations of the SmartMesh technology. During the consensus period, the LAN may drop packets. This may result in outages for up to 5 seconds. Secondly, when there are topology changes, there may be temporary periods where there are package duplications or where loops can occur. Fundamentally, you need to be able to have a loop and detect a loop before you can break a loop. Loops are typically broken within a few seconds. Also be aware that map to root AP recoveries are very slow and can take 1 to 2 minutes. This is necessary to avoid mesh links from flapping and for the mesh topology to encounter frequent rule changes. Also keep in mind that eMAP links with any available mesh AP link, that the LAN segments have APs with different mesh IDs. eMAP uplinks and maps must not have different mesh SSIDs. Also keep in mind that eMAPs with uplinks to any other map on the same LAN segment must have the same mesh SSID. eMAPs with uplinks to any available map on the same LAN segment must have the same mesh SSID. Mesh APs cannot switch to a parent in a different subnet. All meshing APs and root APs must be on the same subnet.